Thanks very much, Paul, and good evening, everyone. And thank you to Meta for the opportunity to speak to you this evening about data analytics and how we feel it can help towards the asset optimization that you guys are all championing, and then specifically how it aligns with CO2 or sustainability initiatives that you're driving. So see if the presentation works. Yeah, so again, just a bit about me. As Paul mentioned, I'm the general manager of CIM. The company was set up by my brother, David. He's based in Australia, and a lot of people feel that's how I got the job here in Europe. I'm a big Tipperary GA hurling fan, so we're hoping that the Limerick team gets some kind of bout of food poisoning or something before the league starts on Saturday. It might be our only chance of pipping them at the post. I do a bit of cycling as well, again, social cycling. I enjoy the interaction between the cyclists, albeit social distanced. But I do enjoy that. It's me and my picture of me ready to go out there in all my wares. I'm a bit of a climate change warrior as opposed to a warrior. I do, as I say, genuinely feel that we're at a very point of inflection around how we consume energy and how we generate energy from this point forward. And the next couple of years are critical. I think history will judge us poorly if we don't make some radical change to our lives and our industry and our energy consumption. And as a result of that, then to make a personal change, I became vegetarian to try and reduce my own CO2 footprint. So enough about me. What I'd like to, I suppose, cover tonight, and I suppose before I dive into the agenda, I'm conscious of, I suppose, three things really, having been on a lot of these webinars, that tonight it's a sunny summer's evening here in Tipperary. Anyway, it's sunny for a while. There's probably grass to be cut and sheds to be painted or kids to be put to bed. And there's also a Champions League match on in whatever, 45 minutes. So my idea tonight is to be as time efficient as possible, and also trying to make it a bit interactive as much as possible, and make it as relevant to what you guys do as much as I can. So to that end, I suppose what we've also done is I've put in some questions as part of the presentation, and Maureen is going to share them according as I ask them, and it gives you guys an opportunity to vote or to select an answer, and they're very simple answers, but it will help flavor the conversation, I suppose, or maybe some of the Q&As at the end, just to understand where everyone is in your data analytics journey, or if you've started to undertake a program like that in your own facilities or your own companies. And the agenda. So like, we're going to give you a small bit about CIM and what we do. And then I'm going to talk about, I'm going to try and frame the presentation in kind of a problem, solution, and value proposition framework or methodology. And the idea of that then, that we can talk specifically about how data analytics can help align with some of the initiatives that you're rolling out in your various companies. And talk about some of what we believe to be the secret sauce in this whole delivery or execution of data analytics, and some key takeaways, and then we'll open it to Q&A. And the Q&A bit, as I say, please feel free to put that into the chat box. They'll go straight to Paul Phelan, who will screen out any hate messages we get from the Limerick hurling fans. I'm only joking. So with the polls as well, the way Maureen's going to work it, guys, is that we're going to ask the question, and everyone has 1 minute to give their answer, and then at that stage the results will be shown to us instantaneously, and again it'll just be used to flavor the conversation. Oops. So a bit about CIM. CIM has developed a data analytics software platform that helps people operate large, complex facilities at their peak performance. And that delivers an economic, but more importantly, big environmental benefit for a lot of our clients. We have an award-winning software platform that we developed ourselves, and we have that in combination with a technical customer success team. And what they do is it allows quick insights to develop operational inefficiencies, and the technical customer success team help on-site facilities teams to realize those savings. So it's very much a collaboration of software and people. And we have, I suppose CIM as a company is probably about 48 people. A big chunk of them are software developers. Then the rest of them are technical, mechanical, mechatronic engineers who have worked previously in HVAC and are kind of world leading in what they do around identifying and helping to resolve issues that come out of the data set. We have the company was formed in Australia, as I said, by my brother David in 2014, and I set up the European entity 2 years ago. We're across multiple industries. So we have a commercial real estate, which is basically offices. We're in retail property, which is shopping centers. Interestingly, we've 60% of the premium and the A-grade shopping centers in Australia, all on our platform. We're in airports. We have some cultural institutions, which are museums and libraries. And then obviously they need to be controlled very tightly from a HVAC perspective. And then we're lucky enough to be operating in the industrial high-tech manufacturing space here in Ireland and in the UK. And some of our clients are the REITs, which is the real estate investment trusts. They have portfolios of investors that different asset types. And then we have a lot of the tier one manufacturing clients here in Ireland. We have medical device sites, we have pharmaceutical sites, we have semiconductor sites, we have technology with data center sites. So we're across a lot of sectors. And I suppose the data analytics is common to all of them, the challenge that they face. And the solution that CIM can provide is not necessarily industry specific or vertical specific. So it's quite good. So I think we're going to lead with first question here, just to keep everyone awake. Just wondering, I suppose, does your company currently use data analytics to improve the reliability of critical HVAC plants? And I think Maureen can share. Yeah, there you go. So that should appear on your screen, folks. If you could click on one of those, please. And then we can see the results. Super. All right, that's interesting. So still the majority of companies are not using data analytics. That's an interesting finding. Thank you, Maureen. Close that now, perfect. So next one. So yeah, I suppose this is the kind of, if you like, these are the challenges, are the reason we feel it's so difficult for the engineering cohort to identify operational inefficiencies that everyone really knows exist, right? We see legacy systems. So that refers to really as the myriad of old and new technologies with limited interconnectivity operating in silos. So you could have different buildings running different BMSs, different versions of it, etc. And it's often difficult to get access to that data set. The multiple vendor one is, I suppose we're seeing a lot of the large facilities migrate to the FM partner type model. And a lot of the critical HVAC maintenance is begin to be outsourced. And you can find, you might have a chill water contractor or an AHU contractor that's operating in isolation. They don't have a common goal or no common direction or guidance when it comes to optimizing their own system. They don't necessarily know what's going on in associated systems. On the lack of transparency, again, we see a lot of proprietary systems, this vendor lock, either across the BMSs or EMSs or even other data sources that might be on site. It might be CHP, it might be anything that we find that sometimes the vendor tends to lock that down. So it needs to be a person from that company that needs to access those systems, which we feel is really the mouse guarding the cheese is an analogy we've used, where the supply chain is broken in that it's very hard for an analytics company to provide independent assessment of the data quality on a site when the data is being guarded by a proprietary system. But technology like ours is unlocking that, and it's identifying these ample opportunities. And the breakdowns, I suppose, refers to the inability to anticipate and prevent equipment incidents and failures, like looking at the data and using that predictive element of data to begin to indicate when plant and equipment is going to fall over. Increasing costs, this is a really interesting one. I suppose it's almost impossible to project the year-on-year maintenance or call-out costs we find with increasing number of breakdowns. But the other factor that's driving this cost increase is the carbon tax, which is, I listened to a podcast by Eamon Ryan at the weekend, and he was talking about carbon tax going to 100 euros per ton. I think it's at about 42 now. So that's a huge cost increase. Even if your energy consumption in terms of kilowatt hours stays the same, your price year on year is going to be going up, and that hamstrings a lot of sites. And the last one then is around the, I suppose, the limited resourcing. We do see a lot of client sites that have the time that the engineers have or the technicians have on site is very limited. They're constantly in that reactive mode, if you like, or that firefighting mode, just to try and keep production going or keep tenants comfort or cool or whatever, or warm, whatever the particular challenges that they're facing. And it's often difficult, I suppose, to try and take a step back and sharpen the saw and look at the data and allow the technician to understand how he or she can best optimize the systems, either by not having the technical expertise or the software to run across, you know, gigabytes of data, and having the time to do that. So it's often a limited resourcing issue. And then I suppose what we see compounding those factors is several of the clients we're dealing with have a very aggressive CO2 reduction target, which is very commendable. But I suppose when we go meet the clients at the coalface, they're struggling to figure out how best to start that journey, or where's the best bang for the buck in terms of investment or in terms of upgrades. And then obviously with manufacturing sites, downtime is the enemy, right? So they want to keep plant and equipment, critical plant and equipment operating, and obviously 24/7, a lot of the clients we deal with are in that space. And then OpEx reduction, certainly on the back of COVID, you know, with the lowering demand and the increasing in costs, every site is laser focused on OpEx reduction. So trying to deliver a solution that ticks a lot of these boxes is exactly where data analytics can come into, in our opinion. And this is where this graphic talks to, but I suppose it talks to removing the legacy system by moving to a data-driven operation, which is the digitization of sites. It's unlocking that data I mentioned previously. It's looking at the data hygiene on site, blending different data sets from your BMS, which is our primary source of data. And then if you have an energy metering system on site, or if you have other data site sources, like I mentioned, CHP can often be one, or water meters, or whatever those different data sources are, blending them on at the cloud, and then comparing data sets and presenting that data back, I suppose, in an easy to understand format, which aligns with a lot of the energy management systems, such as ISO 50001, that clients have, and they need to be able to produce this data in real time to help them ensure that they're staying ahead of ENPIs and significant energy users and stuff like that. On the improved collaboration, so what the data, by unlocking the data and by applying the fault detection diagnostic software to it, the collaboration that arrives out of that, by getting the engineers at CIM side to help prioritize and triage the best opportunities for the on-site team to go after. That brings all the teams together, and it gives everyone a single pane of glass, and it allows everyone to work towards a common goal and ensures that there's working between each other. In other words, if a chill water contractor makes a change to a system that has a knock-on effect downstream to an air handling unit, or to tenants, or to not the tenants, but to employees in a space, that he or she will know straight away that that's had an impact. So that a single pane of glass methodology works quite well to provide that insight. On the fault detection and diagnostics, so that's the software that flags and prioritizes issues. It provides a clear guidance and a path to rectification, including the benefits of doing so, whether it's energy cost or comfort or CO2 or compliance in a lot of the GMP environments we work in. That proactive maintenance, or preventative maintenance, if you like, it's getting out ahead of the equipment failures and understanding, you know, if you have vibration sensors on site, you know, when it goes above a certain level, that's going to indicate that fan or that pump is going to fail in an amount of time. So you can just get out ahead of that and allow maintenance teams to be proactive. The smarter capital planning is around using the empirical data that sites have to better inform CapEx replacement models, and I'll touch on that a bit later in the presentation. And the thermal compliance, I suppose, is especially relevant here with the safe return to work, and ensuring that, you know, the fresh air that buildings will now need to bring in more of, make sure that that's done in the most energy efficient way, and making sure that, you know, that obviously COVID is suppressed as much as possible. But when COVID passes, then to ensure that any GMP conditions that are being controlled, that an area is being controlled to, again, are being done so in the most energy efficient way, whether that's air changes per hour or particulate count or whatever that is, making sure that if a GMP area is set to 25 air changes per hour, as an example, just to make sure that the HVAC is not running at 55 air changes per hour, which we often find is the case. Things tend to change over the years or drift. And oftentimes in a GMP site, they can drift upwards, and the plant and equipment is running much more intensely than it needs to remain GMP compliant. Now, so what the next section talks about is just a bit about how data analytics work, and I've tried to explain it in a couple of graphics. So again, if there's any questions, please don't put them into the chat there, and we can address them at the end. But I suppose the good news is that all sites right now are generating gigabytes of data. As I said, if it's BMSs, which are typically all the digital inputs and digital outputs, and the analog inputs and analog outputs, and a lot of set points, they're all trended and logged on the BMS right now. So there is a wealth of data there just on the BMS. If you can then, if your site is lucky enough to have an energy metering system as well, that data can form a part of the data analytics platform as well. Some sites we work with have wind turbines. Again, bringing that data onto the platform and seeing, what the energy consumption is depending on wind speeds, or the export to the grid, or whatever that is. And other data sources that we've unlocked are like stuff that's process specific. So like you might have compressed air, you might have a sequencer that we can get data from on that, and that would allow analytics to be performed on how efficiently you're generating compressed air. And that's another data source that can help develop actionable insights for the team. And what the way the CIM's peak platform works is, the first step is what we do is, as I mentioned in a slide previously, was we digitize the asset. So that's around getting all the data from the available sources on site, the BMS, et cetera, I mentioned, and then using that element of data hygiene or data auditing, quality of data auditing, to ensure that we don't get rubbish in, because then it equals rubbish out. So we very much spend a lot of time, the engineers that CIM have spend a lot of time ensuring that we get data in 15-minute intervals, that it's correct as much as we can identify, and then once all those data hygiene assessments are done, we send it to our cloud-based system, which is Peak platform, and that runs the analytics, which is the cloud-based solution. So just a matter of getting the data off of the site, sending it to the cloud-based platform, and then that does a series of analysis, and it does that every 15 minutes. So this is constantly running in the background and trying to pick up operational inefficiencies. And just, I suppose, to clarify what I mean by operational inefficiencies is, when a building is, or when a facility is commissioned, or when a large piece of plant and equipment is commissioned, typically it's done in line with a functional design specification, or with a commissioning report, or a specification that a consultant will issue. And the way it has been working in our experience is that will be commissioned on day one of the handover of the new plant and equipment. And then what tends to happen is there's, I suppose, a drift in energy consumption over time, because the analytics is not carried out in real time on that data set. So the variation between where it was commissioned at and where it is operating now can often be quite large. So that analytics that's continual to run will pick up those type of operational inefficiencies really, really quickly. And this is, I suppose, where the CIM technical engineering team come on board, because we know that a lot of people on the call here tonight are extremely busy, and they don't have the time or the bandwidth or the interest in logging into another platform. You have platform fatigue with all the systems that you have on your sites. So what the engineering team do in CIM for our clients is they prioritize and they triage the alerts that the software is identifying, because like the software, like any good software, will identify hundreds of issues. What the CIM technical engineering team do is they prioritize the best ones to go after, whether that's from an energy reduction, or from a CO2 reduction, or from a cost perspective, or safety actually is a key one. Probably I should have started with that one. But oftentimes we can find things that we need to jump all over straight away. And that's what our engineering team do. And then the last bit is they prioritize those issues. And this is, I suppose, the secret ingredient, if you like, where the interaction between the CIM engineering team, who are remote, how that interaction and the collaboration with the on-site facilities team works. And that's really where the rubber hits the road in a lot of these data analytics platforms, in that there are software packages out there that will identify, plenty of stuff that's wrong with your plant and equipment, But in our experience, there's relatively few companies that hold the client's hand in resolving them and ensuring that it gets resolved, and ensures that that savings then doesn't degrade over time again. So this is almost a continual cycle of improvement. And it aligns again with the ISO 50001, that Deming cycle of, that plan, do, check, act. And it's just a continual loop. So I suppose from a site's perspective, from a site leadership's perspective, it's comforting to know that there's an analytics platform continually checking to ensure that operational efficiency is being identified, and that then there's people involved to ensure that the noise is screened out, because a lot of BMS alarms, as everyone on the call here tonight can identify to, a lot of them are noise. And what happens is the diamonds get lost in the rough then, because the pieces of information that you need to go after are so buried in other meaningless tasks that the opportunities rarely get enacted. So by deploying the software with the technical engineering team, a lot of those issues get prioritized, get actioned, get realized, and that process works really, really well. And then I suppose I wanted to touch on this one specifically because I was thinking that some people might wonder where specifically we get data from. So this is an example. As I say, please give me some element of poetic license. Not every site is like this, but typically what we do is we get data primarily from the BMS, and our core expertise is in HVAC. And when I say HVAC, I mean everything from the boilers, the chillers, the cooling towers, the primary and secondary pumps, the fan coil units, the air handling units, VAVs, everything that hangs off that HVAC system. That's where our bread and butter stuff is. But as I say, when we're in the manufacturing space, we're beginning to unlock additional data sets such as compressed air, steam boilers. There's some on-site generation that I mentioned in a couple of slides previous. And then there's some bespoke manufacturing equipment that we're beginning to try and get data from as well. And that's proving a bit of a challenge, but we're still able to get data sent to us in data export format. Some BMSs have lighting on them. And some sites have an EMS, which is energy metering, and that identifies these significant energy users, again, talking the ISO 50001 language. But it's very useful to get this data and bring it into our platform, and then blend the energy data with the BMS data to develop things like the COPs of chillers and stuff like that typically was a manual task beforehand. And if the BMS or the EMS has any kind of gas meters or water meters on site, we can also bring that back to the platform. And we have two ways of taking the data from the site. The first way is a physical device. It's a data acquisition device. We call it a baser. See it on the right hand side of that graphic there. And it basically sits on your BMS network, and it's a hardened device. So it's cybersecurity tightened, or really, really locked down, if you like. We have it on a lot of banks and a lot of government buildings and a lot of airports who are extremely security aware. So we've passed all those tests from a cybersecurity perspective. That collects the data and it sends it out only. So we don't ever write back to the BMS. And a lot of clients we work with like that, because especially in a regulated environment, they don't ever like anyone making automated controls to a BMS. There's too many compliance or quality potential tripwires there. That's one way we have of getting data from the site, which is putting the device on the BMS network. If that for some reason is not a runner with the site, the second way we have of doing it is we program these individual systems to send us the data every 24 hours. So it's like a CSV export. And we get them emailed to our AWS solution directly to a collector email we have set up on that platform. And that prevents, I suppose it doesn't prevent it, it circumvents the need to have a device physically on the BMS network. And that's kind of how the digitization of the asset works, and that we try and get as many data sources as we can onto the platform. When it goes onto our AWS platform, which I showed you on the previous slide is peak, that's when our engineering team get involved, and then there's an interaction with the site. So our engineering team are probably the first people to use the platform or use the insights from the platform, and then develop some savings for the client. So the second question here, Maureen, please, if you could throw it up on the screen. It's, does your company use data analytics to enable a condition-based preventative maintenance program? Yeah, thank you. So yes, or is planning to. It's on your radar, or not right now. Should have some background music or something. Super. All right, pretty even split. Oh, planning to, right? Good. So a lot of people are starting on the journey, which is great to see. And some 25% of people have it. So that's a great result. Thank you. Thanks, Maureen. All right. So the next section then talks, I specifically wanted to try and get the value proposition in as to how the data analytics can deliver asset optimization, to specifically talk to some of the concerns that people on the call here tonight might have. And what I was trying to map out here is the outcomes that you should expect from a good data analytics solution. So the first, I suppose, rung of the ladder, if you like, is that, you know, we should see an immediate energy or a CO2 or an OPEX savings. And when I say immediate, I mean certainly within the first 3 to 4 months of a data analytics solution being implemented. And the reason I say that is such a short time frame is because it goes back to the point about what data analytics should do is identify how plant and equipment has drifted since it was originally commissioned. And a lot of data analytics platforms should be able to really slam dunk the retro commissioning of those pieces of plant and equipment to get them back to how they were originally commissioned. And what happens then is we genuinely see it is a step change in the energy consumption. And I can talk to some examples of that in a second. But that's really, as I say, the first outcome that you should expect. The second one talks about the data-driven maintenance and how we can use data to start making PM scheduling more intelligent, if you like, or more efficient, or the efficacy of the PM's routines, and moving to that condition-based maintenance program. Then around the smart capital planning. So this is an interesting one in that because we prevent plant and equipment from running excessively hard or excessively long, in that we can sometimes reduce its operating hours. You tend to get a prolonged asset life. So instead of having to change the chiller after 10 years, you might get 12 years out of it. So that deferral of capital is very sought after for a lot of companies. Or if there is a company that wants to invest in their plant and equipment, how data analytics can help fuel that decision and help, you know, provide actionable insights to the finance team to allow them to figure out how best to deploy capital. And the last one then is, I suppose, around the equipment performance. You will see less downtime. You will see this equipment running better. You'll hear less thermal complaints in the people in the space saying that they're too hot or too cold, or quality saying there's issues with, I don't know, RH or something like that. The data analytics unlocks that and allows you to run your asset a lot more efficiently. And I'm just going to talk through one of each of these. So my plan here is just to show you screen grabs of the types of opportunities we find. And again, this is really, I suppose, basic in that the first few ones of these are, you're saying, I can't believe Paul is showing us this, but if you just bear with me, I'll show you examples of what we find, right? And the first one is excessive run hours, right? It is really a basic one, but this particular screen grab here is showing it's an office area. It's part of a manufacturing client's portfolio, but it's non-GMP. But you can see the dark blue boxes are the run hours of supply and extract fans. And you can see 75% of them were running 24/7, and they didn't need to be. So a big part of what the data analytics will do is pick that up in minutes. And it just allows us, or a company like us, to pick up the phone to the facilities technician on site and say, listen, will you work with us there to change the time schedule on the BMS? And that's like a 15-minute fix. This particular client saved €2,500 per year just by making this one simple change. So that's kind of the real basic example, but it's just what falls out of the data set. The next one here was picking up when a chiller, there was excessive stop starts on the chiller. And it was even happening 6 hours into what was an after hours period. And again, what we found out here is that the chiller and the condenser water pumps and the cooling towers, they were consuming maybe 32 kilowatts of power according as they spiked. So what we did in this instance is we worked with the on-site facilities team again to tighten up the chiller staging logic to prevent it happening. And it was a savings of €4,400 a year for this particular client. And also it prolonged the life of that chiller, which it's hard to capture here in terms of a pure energy savings, but because that compressor wasn't coming on and off as frequently, we were trying to estimate how long it would take to, or how many additional run hours you could get from that chiller. And the last one then, I suppose, talks about the load balancing between chillers. And again, what we see here is that there was a chiller here, chiller 3, which was in the main plant, and it was operating like at greater than 90% of the loads for extended periods of time. So what we did was we found that by distributing the load across the 3 chillers, we got a better system COP, and that gave the client an energy savings of about 3,150 euros per year. These are big chillers. So there are examples, I suppose, are screen grabs of specifically what the fault detection diagnostic software helps identify, and then the collaboration with the technical team helps resolve. And I suppose what my next slide talks about is just, and apologies, this is appearing a bit blurry on my side here. That's my fault. But what I wanted to do by showing you this slide is just talk about where specifically and why a data analytics platform is different to an energy metering platform. And the reason I showed this slide here is the orange nodes you're looking at here are points that those analog inputs and analog outputs and digital inputs and digital outputs that are coming directly from the BMS. And this software runs these rules across the data set every 15 minutes. And it's automatically identifying these operational efficiencies I mentioned. And this is one rule of about, I want to say about 3,000 rules that we have in an FDD database. And it's bespoke in that if a client has a specific requirement for a rule, we can build it. Provided we can get the data points from the BMS, we can put any kind of control logic into a rule here, and then we can add it to the client's database. So if they have a particular system, they might have purified water or whatever that is, we can build rules around that. And just to talk specifically to this, excuse me, what this rule is looking at, it's checking the available energy that's in the outside air to determine whether free cooling should or could be enabled. And it's asking in this instance here, is the supply air fan, is that enabled? And is it running? And then the logic here looks at outside air enthalpy, and it looks like return air enthalpy. It looks at the chill water valve position, and it looks at the outside air damper. And the particular logic in the rule here says, if there's a difference between the return air enthalpy and the outside air enthalpy of greater than 5 kilojoules per kilogram, then you should be availing of the outside, of the energy in the outside air and cooling your plant. And if that is not happening, in other words, if your chill water valve position is fully open, you know there's a problem. So it generates a fault. And then that's an example, I suppose, of how detailed a bespoke rule is like that. It's telling you that there's an issue with your free cooling in real time, as opposed to looking at a spike on a graph that might be from last week on your chill water consumption, and you just don't know specifically what has caused that. So then there's an element of an analytics required retrospectively. And I suppose that's the difference between an analytics platform and an energy metering platform, in our opinion. And just this next one it speaks to is how it aligns to the data-driven maintenance that a lot of clients are talking to us about. And again, it goes back to the efficacy of the PMs and how we can migrate from the condition-based maintenance to something that's more, I suppose, more smarter. And what we're talking here specifically about is a lot of the BMS preventive maintenance programs that we've seen. And some of the examples we've seen on clients' PM schedules is, stuff like confirm that the damper is actuating or that it's opening and closing. So a lot of times the facilities technician will have to go up with the BMS laptop and stand beside a valve as he or she fires it open and fires it closed and then just ticks a box. And in our opinion, a lot of that type of tasks can be automated, again, by using data and confirming that the actuator is working remotely or is automated. Other things we've seen is, check if the temperature in the mixing chamber is reading correctly. Again, that's something that analytics could do quite easily for you. We actually saw one PM schedule that asked for the BMS panel to be dusted. So we felt that was one that we couldn't automate, but we felt it was pretty low value add. And then the other one was check if the status lights are working in the BMS panel. So again, we'd question whether that's one to automate or whether one could be scrubbed off the list. But I don't mean to make little of it. I'm just thinking of what the analytics platform, any good analytics platform should do is look at refining the tasks they're doing so that we're not by any means reducing the human element required for PMs. We're just making sure that when a person takes a chiller down for a PM routine, that they're preloaded with the exactly what they need to rectify in that chiller to get it operating back to a good COP as quickly as possible. So whether it's a faulty valve or something that's happening in the chiller, that they can change it really quickly, to have that valve with them, etc., and using the data from the PMs to do that. And the last bit then speaks about, I suppose, how we can continue to refine that preventative maintenance over time. So this one speaks about the smart capital planning, and I'm going to try and jump out here onto our platform. So if you bear with me a second, it's easier to talk through this one in real time if everyone can still see my screen. I hope we can. So what you should be seeing now is a dashboard that we've built for a client that asked us specifically to help them decide what plant and equipment to change, because this particular client had been advised by one particular equipment vendor that the piece of plant and equipment was coming up to 10 years old and it needed to be changed. And it was expensive. It was 250 grand for this piece of kit to be changed. So the client came to us and said, you know, is this true? Does this need to be changed? So what we did in that instance was we used the data to show the client how the piece of equipment was running, and then we're able to compare it to another piece of equipment and say, listen, if you are investing capital, here's a much better way to deploy it. So instead of replacing equipment A, maybe replace equipment B, and you'll get a much quicker return on your investment from a financial perspective, and you'll also get a much bigger bang from your buck in terms of CO2 reduction, which is ultimately what a lot of companies are trying to achieve by replacing plant and equipment. So this is another analysis, if you like, that came out of the back of this. This is a particular client that asked us to use the empirical data that they had to best inform the consultant that they had working for them on how to change a chiller that they had on site. So this is real data from a client site showing the run hours on the left, and then the percentage of the load that each of the time it spent at that load. So you can see the majority of the time is running between 40 and 70% loaded, which is probably where you want your chiller to be. But they were sold a chiller that would run at a good COP at low loads. This was the green line here you're looking at is the design COP. So that's what they were sold. But what we were able to do is plug in the actual COP based on the data set that's coming from the BMS. And this shows, it shows that it was running very poorly at low loads. So you can see the COP was just above 1 at those very low loads. Now, it's not a lot of the time it runs at those, but still the delta between what they were sold versus what is actually running in the field were two different things, and they were diametrically opposed in some instances. And then we said to them, can we get the data from the new chiller, the specification of the new chiller? And we were able to plug in this empirical data into that new chiller model and visualize what it would look like for them without them having to ever deploy any capital. And this is what a low load chiller in this instance would look like on the client site. So you can see it would make sense to invest in something like this. And the difference between this 12.4 COP and the 3.19 it's getting at 20 to 30% loaded is the savings that they would make. And it's quite, in this instance, it was quite a worthwhile investment. So that's an example, I suppose, of an actual client site and using their own data to inform them around capital replacement programs. And again, just thinking of the asset management, I suppose, cohorts that are on the call tonight, this might resonate with some of what you guys do. I'm hoping it does anyway. So let me try and jump back to the presentation. If I can just, if you bear with me 1 second now. Yeah, so hopefully that's back and people can see that screen. Yeah, and the last one then is I suppose around the equipment performance. So this is around, I suppose, avoiding that dirty word that's downtime in a lot of the manufacturing sites. Nobody likes to experience it. And the example I'm showing here on the screen is, again, it's a screen grab from the analytics platform that we have, the Peak platform. And the green line here is showing that the supplier pressure, the historical value that it was running at, which is 325 pascals. When we got the functional design specification, we discovered that it was way above what the supplier fan could achieve. So as a result, the purple line at the bottom here is the VSD on the supplier fan. So you can see it's running at 100% flat out, trying to achieve a set point that it can never do. So we asked, in this instance, the software generated an alert. The specific resolution was for the technician to go down and check when the supplier pressure sensor had been last calibrated, or if there was a sticker on it to indicate how old it was. When he went down to the duct, he found that the static air pressure sensor had come out of the binder pocket that it was in. So he essentially reseated the static air pressure sensor, and the green line dropped back to 200 pascals. In other words, it began to read back in control. And you can see then what happened with the VSD. It backed way off. It went from 100% down to maybe 20%. And this was an 18.5 kilowatt fan. So it went from 18.5 kilowatts down to maybe 4 kilowatts. And it was an extensive saving for the client, but also VSDs don't like to be run at 100%, as everyone, I presume, on the call knows. So this was a way of ensuring that equipment will run for longer. And again, hopefully in this instance, it will defer that CapEx spend, like if that fan did fall over, or that pump, whatever it was. And we genuinely feel that it's the merging of innovation with people. And like, as I said to you before, everyone on the call here is really time poor. They're in that, reactive mode a lot of the day. There's an element of platform fatigue. There's a long list of projects you need to get to. The last thing you want is another, report landing on your desk saying the 50 things that are wrong. What we find is very much a USP for CIM is the ability for us to do that hand-holding with the client to decipher exactly what the site needs to go after, and then to help them resolve it. And having that remote HVAC experts in their corner, if you like, which is the CIM engineering team, to pull the levers to advise their technicians how to execute on what the platform is identifying. That's the real secret sauce we feel. And like a lot of times CIM will tell our clients that it's very much a team sport. In other words, we need an element of engagement from the on-site facilities team for this to work. And once we have that kind of understanding from the outset, it normally works very, very well. And we get some really quick wins on the board very, very quickly. Excuse me, excuse me, because and again, conscious of the fact that a lot of platforms will identify plenty of things wrong. It's the realization of the savings is where that, where the rubber meets the road, and where the tricky bit gets to in a lot of the analytics platforms, that they're able to identify lots of things that are wrong, but in terms of getting those executed for busy facility managers or energy managers or asset managers, it's very, very difficult almost. And I suppose by merging the software with the people element, there's lots of, I suppose, non-energy benefits in that you definitely get the energy reduction and the cost reduction. That's the first achievement. But you also get to empower these technicians who genuinely, in our experience, want to be able to help and want to be able to reduce the site CO2 emissions, but oftentimes they can't. And it upskills their on-site, the technical knowledge. We find a lot of sites have, we call them Mr. Miyagi's, where one or two technicians will know everything about the site. So it's just getting that knowledge out of their head and baking it into some rules that then can be disseminated to a wider audience. And then everyone learns from that person. If that person leaves or if that person retires, then, that knowledge is not lost. It's a big part of the data analytics platform. And again, it improves energy literacy on site, and then that drives behavioral change. So it makes sure that, if a shortcut is taken to make sure production stays going, that shortcut then is retrospectively fixed, or, we'll hold people accountable to say, listen, you changed this set point last week. Can you please go back and put it back the way it was, or fix it? And that's quite powerful. As I say, that's what we genuinely feel is the secret sauce. And I know these might be a bit small to see, but this is just talking about how the engineering team at our side work with the on-site facilities team to close out tickets. And I suppose tickets are like another operational inefficiency. The one on the left is referring to a chill water plant optimization and the issue that was found and the resolution that was involved in it. And we use this kind of a workflow to log all the issues and the history of it. And the one on the right talks about some hot water system issues as well. But the examples of these tickets are baked into what we have is a workflow management dashboard, where the technician will log into this and they'll see any tickets that are assigned to them, and then they'll typically interact directly with the technical engineering team at CIM side, and then we will work on moving these tickets from left to right, from open to closed, and then we will ensure that, as I said, once the issue is closed, that gain that we got in terms of energy reduction or improved safety doesn't reoccur again. If it does, the unique asset ID is part of the ticket, and if that happens again with that plant and equipment, it will come back into the open, but we'll also pull in the history, so we'll know that this issue was addressed only 2 weeks ago or 3 weeks ago or something like that. And that workflow management is super, and it's very simple, it's very intuitive, and it's a very good way of getting what we found as facility technicians to buy in and to get some momentum behind what they're doing, and for them to be perceived in a good light, because a lot of times, in my experience, the facility guys tend to get kicked in the face a lot, and everything is their problem, and people are always giving out about facilities, and this allows them, I suppose, to change the narrative, right, to allow them to get out ahead of issues and to be proactive in terms of identifying and rectifying issues and making sure the plant is operating more efficiently. So the key takeaways, we're nearly there, and thank you everyone for your time. The first bit of information I have is that, as I said, sites are currently generating gigabytes of data. There's no additional metering needed. The technology CIM have is BMS agnostic. It doesn't matter building type, building age. Now, obviously, the older buildings may not have as many, may not be as data rich as some of the newer ones, but certainly there's an 80-20 rule there around getting that data and optimizing what you can. But the good news is that, you know, you have everything you need right now to start. Data analytics, every site we go into, we talk about, or we hear people saying, listen, we've all the low hanging fruit identified. I think if there was a data analytics bingo, I think low-hanging fruit would be one of the words that everyone would hit the buzzer to when they hear. And I'm sure, I don't mean to make light of it by any means, but like when we ask clients what they have done in the low-hanging fruit space, they say, oh, we've changed our lights to LED, or we've upgraded our AHUs. So they're immediately defaulting, I suppose, to CapEx type projects. And what data analytics does in all the sites we've been in is it resolves that operational inefficiency. So it eliminates the waste. And that's a huge part of any site's consumption. And it's not any site's fault. It's just the way things drift over the years. So it's really immensely powerful as to what data analytics can unlock. The collaboration, as I said, between people and software is vital. It doesn't work other than that. The technology should be used as a way of empowering teams instead of replacing them. And again, a key point here, and trying to tie it back to the topic of the evening, is, I suppose, how data analytics can form part of the CO2 reduction strategy. And in our opinion, like, data analytics should be the first cab off the rank every time, in that it's you know, looking at operational efficiencies, it's reducing the waste, it's squeezing out all that waste before anything like capital is deployed or a PPA is signed or any type of major investment or seismic change in terms of what you're trying to do from CO2 reduction. Because if you don't reduce the waste first, that's going to be baked into whatever you're trying to reduce in terms of CO2, and that's going to be quite expensive for any site to do. And in while I suppose trying to wrap it up here, the asset optimization, it isn't a primary driver of data analytics. Interestingly enough, as I was reflecting on this slide deck, and I was trying to finish on a high note here, I was going to say that asset optimization is the primary driver of data analytics. It's actually not, which is interesting. It's the I suppose the ability of the analytics platform to deliver like safety, to deliver energy efficiency, to deliver uptime, to improve thermal compliance. And then one of the outcomes stitched onto that list of outcomes is asset optimization. And I think that's it. Yes. So look, I'd like to thank everybody for their time. I'd love to hear some questions. Apologies if I ran a bit over, Paul, but I think we have a few minutes for questions and answers before the Champions League kicks off.
We do, Paul. Indeed, we do. I think there may have been an issue with some of the questions coming in, but there's a few here, and I have one myself, which was quite interesting from beforehand, which was about what you call the data lock. Vendors that weren't very or were reluctant to give out their data. How do you get around that? Because I guess if you're on old legacy sites, they might be reluctant to do that, and you have to give them hand over some money, or how does that normally work?
So I suppose there's a couple of ways we found of unlocking the data. Like the technology we have doesn't violate any kind of proprietary systems or doesn't hack any type of front end like that. But when our device sits on a BMS network, it sits essentially like a read-only outstation, essentially. So it just listens to the BMS traffic that's flowing. And a lot of times, if it's a backnet system, we can get that data offsite and then we recommission it at our side using the FDS and the O&Ms that the facilities team have. So that's one way of doing it. The second way is, I suppose, we can kind of usually get the client to tell them that we want this data. And a lot of times they will try and charge the client for it, but I suppose the client can often call foul or claim that they're, element of skullduggery charging them for their own data. So that's often an interesting debate. But I suppose on that CSV file export, clients can tend to ask the proprietary data system owners to send that out to us. So they need to send us out the data, but they also need to send us out a table as to what it means. So there's a couple of, as I said, tripwires there. But as I say, on the billings we're on, Paul, we've not failed to get the data from any site yet. So it is a challenge, but as I said, we have some good people working on our side that can unlock it.
Okay, that's great. I've got a question from Connor Cooney. He says, "Hi Paul, does the software permit automated analytics which generates proposed actions without human intervention?" So I guess that's down to your engineers. Do they always have to intervene, or is there some cases where the data comes in and it automatically spits out what you should do?
So yeah, to answer Connor's question, it does absolutely. So when it generates an alert, it will also, we have a knowledge database, it will also select the solution that the software is recommending that this on-site facilities team take. So that I suppose identification of what steps need to be done is something that our engineers will have in their hand when they're reviewing the ticket. And a lot of times what the engineers do is they double check that the solution that's being proposed is actually the correct one. So I suppose to answer Connor's question, there's any one of our clients has access to the platform. So if a technician logs in and sees something like, one of the recommendations might be to replace a faulty temperature sensor or replace a static pressure sensor, that's the technician can by all means take that action on him or herself and close that out. And then just circle back to our engineers and say, listen, I've resolved that ticket number 49 there myself. And then our engineers will confirm that, either the chilled water valve is after closing or the hot water valve is after closing or something is after rectifying the issue.
Okay, great. One question from Ed Burke. Can you elaborate on how data analytics aligns with the CO2 reduction strategy?
Yeah, and I suppose that's kind of what I touched on earlier around how to ensure that, that client, we do see a lot of clients that have very, very aggressive CO2 reduction targets and they have a very looming deadline in that they want to be carbon neutral by 2025 or 2030. And like that's, in terms of a seismic shift in the operations that they have in Ireland, it's a quantum leap to try and get from where they are now to be carbon neutral. And they, I suppose, sometimes perceive that the only way to do that is to, either 100% go to PPA right now and procure green energy with guarantees of origin to back that up, which are quite expensive, right? And also, there's only so many wind turbines being put on the grid right now. So that additionality clause is often a trip up for the large multinationals, in that if you can't prove additionality, then the goose don't, well, not the goose will be there, but I suppose the condition around ensuring that their investment is driving additional supply of wind isn't often possible because you have planning delays, etc. So what we're saying is that the first, if you like, the first step on the CO2 reduction journey should be the data analytics, because it will do what I've highlighted in the presentation, which will be reduce the waste, but it will also ensure that every step that the client takes along the journey, whether it's a equipment replacement program, or whether it's on-site generation, or whether it's, eventually the PPA procurement, that data analytics underpins each step of that. And you have, visibility on what exactly how to deploy your capital to ensure you get the CO2 target in a realistic time frame.
Okay, great answer. Great answer. Listen, we've got a couple more questions, but they're quite lengthy, and I can see we're running short on time. So I think I'm going to wrap it up there. And thank you very much, Paul. Just one comment from me. What I love about this solution is that you don't have to do any physical installation. That the sensor is already there. Everything is already in place. All you're doing is taking the ones and zeros and putting it up to your cloud, and then coming back with ways to make your plant more efficient. So the question is more, why wouldn't you do this? It just makes it's a win-win for everybody. So thank you very much, everybody. Paul Walsh from CIM, their website is cim.io. Thank you, Maureen, for organizing the webinar. This webinar will be available on the Engineers Ireland YouTube channel. And I'd also like to thank the META Asset Management Events team. So Tom, John, and Jerry, thank you very much.